were you all gonna tell me that my mic was off? I was playing some tunes, I was talking to you, and my mic was off the entire time. When were you all gonna tell me? Unbelievable. Yes, 5 more minutes today, that's what we need. This is... So, okay, let me repeat myself. Well, first things first, go. There. Now, next, I said that this is the Bras and Kids video, which is a video about Bras and Kids, or most specifically a video about linear algebra. And so that's what we'll be working on today, because I only need like 5 more minutes tops to finish it. So that's what we're going to do today, simple as it could be. Oh jeez, it's already... right away. Oh, microphone, no, wrong me once. Shame on me, wrong me twice. That's still kind of shame on me, honestly, I should have turned it on, doesn't matter. Okay, so first things first, right away, let's just start rendering something to not waste any time, because time is a wasting, can't spare a minute. There we go. Or actually, I suppose I should move it a little bit more to the left, and the reason why we should move it... Actually, no, let's move it to the middle one, am I talking about? I can move it later, yeah. There we go, render animation. Now, another thing, this will be a 5 more minute stream, because I only need 5 minutes to finish that video, but at the same time, I don't have enough time to not work on anything else in the background. So I am also going to be working on the Taylor series video and the time evolution operator video. And ideally, actually, the time evolution operator video should be more important, I think. I would say. Yes. Okay. That makes sense. This guy has a Taylor series. Yeah, Taylor series. It's honestly shocked that I haven't made a dedicated video of Taylor series so far. I've only explained Taylor series in the Oilers video, if I'm not mistaken. I think it was in the Oilers constant, or it was something with the Oilers constant. I don't remember which one. So for my mistakes, so kind of like saying that the image of a particle, next we have wait. The particle will be the same image as T1, T0 and T1 filters together. Hope that makes sense. Makes sense. And just from this animation it should. Second, and then next we have the time evolution operator of t plus dt. Right. Time evolution of our state from the initial t to t plus dt. How does it evolve then? Well, that's a good question. So basically what we're talking about here is give me. We're talking about obviously this t plus dt from t naught of the state alpha at t naught. There we go. This is what we're talking about. Do we need some kind of motivation for why we're doing this? Asking question of what does this mean? Well, if we go back to our timeline, then what this means is us starting with kind of image particle, then applying a filter that gives us an image at this point in time. What is that point in time? Well, brilliant question. It would be t plus dt, yeah. And where is it in an infinitesimal distance? Infinitesimal, geez, infinitesimal what? Not distant. What's the distant word for time? Time period, no. Distance. There has to be a distance equivalent in time. My mind's just gone blank. I could have sworn that existed as a word. Now my mind just went blank. I cannot remember. Okay. We can turn off then, and then back to it we go. 5 more minutes. I could actually try to do the progress tracker thing where I once again set a time limit for myself, although yesterday it failed miserably and I didn't get nearly enough work done. But this time I will, because stage 1 is denial. Yeah, so this is meant to be our vectors with linear maps. There we go. Now since this thing on the left is supposed to be a map, not a vector, then you better believe it that this is going to go right. Like so, and this is going to transform. Brilliant. Absolutely brilliant. Wait, left to right, right to left. A, B, C. Oh, that actually threw me off for a loop. When you have A, B, C, when you have X, Y, Z, then hold on. Vector times a covector. What was it again? It took me a while to understand linear algebra, and even now there are things I need to get better at / understand more. I will say that with this video, I'm actually quite pleased with it, simply because if I know for a fact that if there was a video like this when I was learning linear algebra, I would have understood it way quicker. I was genuinely hoping for like a pretty simple answer, just to get a quick, just to get a really quick cheat sheet of which way it's actually going. But nothing can be that good. Alright, fine, matrix multiplication, that's the closest one. 1 1 1 B 1 1 by 1 1, but then it increases that way. So this is our first one, this is our first one. So it's gonna be XA, yeah, okay, that's correct. It does in fact increase to the right, which means this is the way it should lie. There we go. Can I lower the samples a bit? Not really. Splendid. Okay, back to the time evolution operator. We're interested in an infinitesimal. So basically, as we have this time evolution, we're going to have a timeline. We're starting at t0 and we're trying to evolve it up to t plus an infinitesimal distance of dt right here. Decimal. Distance for time. Is there genuinely no word for it, or can I just not recall a single one? My mind has gone blank. Distance, but for time. It would like distance, but for time instead of length. I am going to lose my mind. In the time, that's infinitesimal distance further. So that's why we add dt. This dt here is really the same kind as in our derivatives video. Okay, so with that in mind, even as Taylor expander. Right, we'll need to Taylor expand this. And this is actually going to be a bit of a tricky Taylor expansion because we'll be using the omega because we have no idea what the derivative of our Taylor expansion actually is. So we'll be just using a blank omega. Wait, hold on. Uh-oh. Not great. Why did this turn pitch black? Oh, bloody hell. Why is it always gotta be something with you? No, the floor is most certainly there. What's up with the floor? What happened to the floor? Why is it pitch black in the render? It's absolutely bloody always something. Please tell me it's just Blender forgetting some values. Yeah, it was that simple. Blender just forgot that the floor exists. That sometimes happens. Do it again. Jeez, my goodness. Now is not the time for the renders to mess up. Absolutely not the time. I have 5 minutes to finish a video. Taylor expand. We can actually. Okay, I suppose this would be a bit of a better time for the Taylor expansion video than just that we can click it in more nicely. Right. Taylor. 0 point. All to go the values on list 3. So basically, we have our function. We don't know what that function is, but we do know how it's changing. And just to make it that more difficult for ourselves, let's say that we change it at 0 point. In that case, at the 0 point, we can tell what the function is equal to. We can tell how it's we can tell its slope, its curvature. I don't know what comes after curvature, to be honest. Curvature of curvature. Derivative of curvature. I suppose it would be the curvature of curvature, wouldn't it? And so on, so forth. This is because let me have a thunk actually. Okay, so this will be a bit tricky actually to explain, because we need to start with our function that we're trying to get. We have all of the derivatives evaluated at 0, but that's it. We don't have the function itself. The way I'm going to do it is I'm going to start with the 5th order derivative at 0, and then I'm just going to call it d5. I'm going to do it the exact same way as I did in the olden video. Then what? Well, then we're going to take this, integrate it, and according to the rules of integration, what we should get is we should get this integral to be equal to d4. Now the question is, what is d4? Well, by that we will know that d4 will be equal to d5x plus c. Can this work? Oh, I actually don't... Wait, it can only work if we assume the derivative to be a polynomial, can we not? Because otherwise... Well, actually... No, wait, we're gonna get... Oh no, this is a bitch. Hold on. Oh, this is really tricky. Oh, this is really tricky. Yeah, this is really tricky. Hold on, Ash has written a paper about the Taylor expansions, so if you don't mind, I'm going to open it up right now. Unfortunately, the very conveniently initial chapter is about scalar value Taylor expansions, which is what we're interested in. Ah, damn it, we already started with it. That's a pickle. Okay. Okay, now we take this, we're gonna make it smaller just for the sake of gaining some space back on the screen, and then you to this. Beautiful. we may run out of space, in fact. This is going to be a bit of a tight fit. Because what we're going to need to do is we're going to need to fit in this entire equation. That's doable. Alright, in the meantime, as this is ready, I'm actually going to make myself some coffee. If you don't mind. And you really shouldn't mind, because I mean, why would you mind? That'd be a bit of an odd thing to mind, wouldn't it? I can feel myself lacking the entertainment factor. So this will help. Anyhow. The problem with the Taylor expansion is that you take the... It's not really mathematical, my approach. And then I really should change. So basically, if we assume the derivative, wait, let me do it on the Discord whiteboard, simply because it's a bit easier to handle. There we go. Okay. So, basically, if, hold on, it's getting a bit loud, I get that. However, we need to clear some space. There is enough space right there. Well, beautiful. So basically, we assume f to the fifth to be d5. In this case, this d5 would be a function, actually. It would in fact be function. We're gonna do the same thing for all the lower ones. So d4 will be equal to d4, we're going to ... right. It's just notation so far. So far it is just notation. Also this should be x, not n. I don't know why I've not done n. That is very much a big no. N would be for derivatives. So, then, if we take an integral of this right here, is a problem. My coffee is done, so first pour it into the kettle. Okay. The problem is that we're assuming it being multiplied by x, which is simply not always true. So for example, in order for my way to work, we would need to multiply this by x, and then do plus c. Unless we treat the d5, I'm an idiot! Because we're considering it at 0. I am such a moron! Yes! We're taking that function at 0. Oh, that's brilliant. Now this is a value. This is a constant. Which means now integrating this, right, will give us d4, which means d4 will be equal to d5 x plus c There is one problem here still. I'm silent because I am thinking about how to fix this. I mean, the nice thing about this is that solving it is kind of trivial if we get to this step, because then we can just say, okay, let's see what the function f of f to the fourth is equal to add 0, and then this x becomes 0, so this becomes 0 plus c, and this is still d4 because we evaluated at 0, so we have d4 is equal to c, which means this becomes d5x plus d4. The only problem here being that this x doesn't make any sense. I'm dying. Okay. Oh, I'm so close. Actually, I need to say that we can just duplicate this. I really hope this will be readable. Oh, goodness gracious me. Are you under the floor? For a second I thought I would need to reapply all of these materials, and that would have been a pain. I can pack it more compactly. Don't exit. Not yet. Okay, I can pack it more compactly. The reason why I haven't is because I was trying to align everything better. And just to be a bit quicker, we're gonna render an image instead of an animation. Okay, splendid. Now, I'm gonna have a sip of my workahol, and then we're going to have a brief look on actually how much of the video is still left to be done and just how bad it is. Because I really cannot stress enough how not only do I need to finish this video today, but also how I actually should have finished it yesterday. And the fact that I didn't is a problem. So, it is really important that everything goes according to plan. Okay, this guy right here will be really trivial. And then all we have is this segment. Does this segment talk about anything difficult? The states, that would be kind of difficult. Other than that, not really. That's good. Okay, I think it is doable. Now, in this section of the video, I'm talking about different notations for linear maps. And so obviously we already have the vector covector notation, we have the function notation, but then I also added three additional ones. The last one would be bras and cats. These ones, I genuinely don't remember what I had in mind. Well, one of the notations we can use the notation of a map. As in. Obviously I don't have it off the top of my head, so let's look it up. Linear maps. No. I'm looking for R3 with a function that maps it onto R1. No, this. We can just, I feel like we can get the notation better from just the article and maps. Not that kind of map, disambiguation. Not in fact what I meant. There we go. Or actually, we can just grab it from here. It is. Okay, brilliant. In that case, we can note it down as... We should be able to just note it down as F colon math bb R3 and then right arrow math bb R like this. That should also be it. I messed up, it should be default. This will be our result, which for now we can just leave as white. Theoretically it should be green because that's the color I've been using for scaleless, but we can leave it as such, that's fine. What other notation is there? What other notation I had in mind when I was scripting this? I can do it with sums, I suppose. That's also sometimes from time to time. Okay, I suppose we could do it with some. In which case, but the problem with the sum is that the sum doesn't really capture the fact that a covector is different from a vector. You see, the whole point here is that despite both of them being effectively just three numbers, a vector is three numbers as in three values, whereas a covector is the three numbers that describe a map onto those three values. And that's the point I'm trying to accent here. So I'm thinking if there is a way to accent it better. Hence why this notation for a function. Because that's the function. Coffee is just a linear map. Coffee brings me to an excited state. Quantum mechanics pan, you're welcome. All right. It is such a comically childishly colorful video. It looks like a cartoon for kids, but it's linear algebra. I'm brilliant at my job. Okay. What other notation could I use that accents the fact that linear maps are supposed to be different, that covectors are different from vectors? Oh my goodness. It's a corresponding vector. So in other words, every column j equals 1 up to n has a corresponding vector whose coordinates are elements of column j. Yes. So that's the matrix, but we'll get to the matrix in the future. We won't deal with matrices just yet. Oh, this is actually neat. Right. This is a bit about from Kovac's point of view. Oh, that's rank. Coffee just maps make it onto the excited plane, exactly. No, screw it. No one will know. I'm going to cut this and no one will know. Unholy thinkable. You will not know. You have no idea what I'm doing right now. You will not know that I've cut anything from this segment. You will not know. Langu. Oh my. Oh, hold on. This is going to be a bit confusing. F. V. Rangu. Now this is not quite the way you normally note it down, because technically, I mean, it's not that big of a crime, I suppose. It could be worse, certainly. I mean, the bracket notation is correct, don't get me wrong with that. It's just that, there's no cut. Exactly. Glory to the ministry. Big brother is proud. Actually, I don't think I had to cut anything. The thing is, I didn't cut anything because there was nothing to cut. And only enemies of the state would suggest the contrary. Oh no, the music is out of whack. Okay, brilliant. So, now we're going to move this one away. We're going to move this one away. We're going to move these two away. And we're going to move this one full screen. Brilliant. Okay, splendid. Now, what was I doing? Oh yes, right. I was working on the Taylor experiment. So basically, we say that our derivative at 0, because we're the entire time we're talking that these are the evaluated derivatives at a certain point. So these d's will refer to that derivative evaluated at 0. In that case, we have we can evaluate, we can check what the fourth order derivative would be at 0. By integrating. So we integrate d5 but then we need to treat d5 like a function, which is dumb. Because then what we need to do is we need to define like a temporary function, g of x, which is equal to d5, which is a constant. And then we need to integrate that function, dx. And only then does it make sense to say d5x plus c. Ah, goodness gracious me. Hold on. I'm just trying to imagine how bad it is. No, Ash went with something completely different. When I say completely different, I mean like starting with the Taylor series. So Ash went the route of define it and then also have a remainder and then just proving that it works. In my case, I want to get to this point. I guess I don't have to justify it too much, and I can just at the end link to the paper. That's tempting. That's actually really tempting. Not about an idea. Okay, in that case, it's really important. I really hope I understand what it can do. Then we're gonna have the next chapter, which is derivatives, evaluated derivatives. What is it? Arbitrary function. This would be some kind of arbitrary function f of x. What function would be equal to? No idea. We don't actually know what would be equal to. I really hope they understand, because that's the problem we're trying. That's very obvious. That's what we're trying to do. Basically, trying to figure out our function is just by knowing how it's changing at 0, or how the change is changing and how the change of change is changing, so on and so forth. So, how would we go about this? So, oh, don't do that. First, why are you changing this entire block of text? Absolutely not what I meant. First, there we go, fixed. Constants, right? And then utilities. Okay. So, first things first. Like we have our function, we can define another function that would be the derivative of our function. Slowly, but it would generally Yum. I'm sorry, I blacked out for a second. Right. Why it's a derivative? Just go over the graph and try to intuitive sense of why it's high here, low here, so on and so forth. Irrelevant. Pointless. Promise. Understanding graphs by memorizing them does help. And so with that in mind, let's take another derivative. Okay, brilliant. Could label it bases and then states. That would make this a bit easier to understand. Time draws closer to me being able to create my own MOSFET. Ooh, really exciting. That would be quite a flex, I do have to say. Making a second of your own MOSFET. This. There we go. We're at 6 minutes, not bad actually. Just not bad, so close, so close. So really comically close. Okay, let me just delete this, all of this at the bottom, these right here as well. Just clean up this space a bit. There are way too many things. I'm not gonna delete the equation at the top because that equation is actually what we're gonna finish the video up with. Oh, this is actually really nice. Oh, this is actually really, really nice because this right here is our bra. This right here is our ket, and this in between them is a matrix because it's an operator. We consider it, analogous to a matrix. It's infinite dimensional, so we say operator, but analogous to a matrix, and that's what the animation is actually going to be next. That's really nice. I'm getting excited over silly things, I know, but I just like it. Now, process. I will need to set up the entire thing in Blender, and only then could I actually, yeah. Ideally for the Taylor expansions, I would set up the entire thing in Blender first, and only then work on anything. Because first I need to make sure that my approximations will be close enough. Because they might not be. I'll be approximating all the derivatives. And as such, I'll be also approximating Taylor expansions. So right here, we needed graphs generator. Then we will also need derivative evaluator. Then we'll also need Taylor expander. expand. Actually, Taylor expander can just be there if we have a derivative evaluator. Then we would need Taylor equation generator, and then Taylor equation generator evaluated. These are the things we need in order to make this work for now. I will most likely be working on this video on the bus, and I just think it's hilarious. I'll be working on it on a Flixbus most likely, and I'm pretty certain that they have just outlets, which will be so convenient because I'll be rendering all of this. Let's take another derivative. And now repeat process. Yes, so questions like why does this function up here? Why does it go down here? So not etc. etc. No, I just realized something. I just need to message someone about. I just need to message a guy about the thing at the place that I'll never forget. I'm thinking of doing a dual masters in E and math, or do it on the side of work on PhD. We love working time by the side either. Somewhere I need to work. I mean, that would be great. I will say I'm probably thinking about that. I am extremely biased, but in my opinion, it's a great idea. Mathematics is. I don't think mathematics is something you will regret getting a dual in. I suppose pun unintended. But I don't think you're going to regret having a dual in it. Simply because it's extremely useful once you get to PhD level, basically no matter what you're doing. Especially if you're working with electrical engineering. Oh, look at that, I perfectly calculated this. Beautiful, and now one last thing we'd like is actually right here, and those would be the groups of one of them. Some of the groups in here have what I'm looking for. The problem is I didn't name any of them. It's not 6, not 7, it's not 8, it's not 9, it's not 10, it's not 11. What even are these? Oh, they're devs. That makes sense. Okay, so it's not 11. No. They're constants. 2. That might be it. Bless me, isn't this? I'm leaning more towards pure mathematics than applied. I assumed so, yeah. That is what I assumed. Alright, math truncated modulo of 3 and then divide and floor. Divide by 3 and then floor. There we go. So this should be our x coordinate, should be y coordinate, so then we will combine x, y, z. Like this, x and y. Beautiful, the only problem being that this is going in the wrong direction. So -1. Splendid, and then all we need to do is just vector math. Vector math. I said offset it. -1 and 1. And there we go. And then ABC, XYZ, and subscript would be really convenient here actually. For which I do also have a node group. I just don't remember which one it is. This one, yes! Oh, thank goodness I found it. This one is with subscript, which means we can actually do M. And then we can do subscript of value to string actually. 2 of them, and then join the strings. This can work. Yeah. This is going with a minus. That's absolutely incorrect. There we go. We could have another value. I will just go separately for this one specifically. There we go. I am so good at what I do. It is honestly incredible. And then one last thing remaining would be to give them all a color. So stone an attribute right here. And then, well, it's a good question then, what? I have an opportunity to have it change both ways. Or I could have it actually be, oh, hold on, I have an idea. Combine color, but with hue situation value, because situation will always be 1, value will be 1, like this. And hue is the only thing that would change. The way we'd like it to change, oh, why am I doing this to myself? This is so unnecessary. Because the way we'd like it to change is we'd like to imagine it on a circle and get the angle, which I've done a lot of times in the past, and every single time it's so unnecessarily annoying. Because in order to get there, we have the x and y coordinate, that we do. The nice thing about this is that this can be so easily expanded, as in integer power square right here. Then the same exact integer goes in right here, and then congrats, we have a script. Well, if only we remove this. We have a... Oh, wait, hold on. There we go, congratulations. I said... Need -2 now. Oh, jeez, 5. -1/2. Subtract 1, divide by 2. There we go. Now we have a generator of n-dimensional matrices. Because I am just that incredible. We're gonna disconnect it for now. And then what we will have is tangent of opposite to adjacent. So that means arctangent of opposite to adjacent will give us the angle. The only problem is that we need to account for the fact that it's the negatives have to be in the negatives. So what we do is we take the magnitude doesn't matter, which means we can just straight up take the coordinates, math divide opposite but by adjacent. No, we can't. We cannot, because damn it, we need to add to both of them. No, subtract from both of them. This. Which, now I think about it, would be much easier done if we just subtracted on the very beginning from the iteration instead of normalizing. Yes, that's true. So we plug this in. Why am I trying to be so proper about this? So unnecessary, so unbelievably unnecessary. No, it has to be after the fact. After these. How do I normalize it? That's the issue, it's going too far. Oh, it's because I'm doing it with a floor. Is that a problem? I don't know. Yeah, it's because I'm dividing and then flooring. When in reality I should just be... This is terrible. This is just utterly terrible. What do I need to do is I need to subtract from this and this. There we go, normalized. Yes, thank goodness. The reason why it's important is because this right here now will give us normalized coordinates. And then, well, not normalized, only centered, sorry. They're not normalized. But the reason why them being centered matters is because now we can use them right here. No, wait, we can first delete this. Opposite divided by adjacent. That into the arctangent. And that into the hue. And as you can see, it looks like garbage, which makes sense. It should, because so far arctangent will give us a wacky value. It goes from -1 to 1. Add 1, divide by 2. Better. But then what we need to do is we need to take the height and take the sine of the height. Then multiply the result by the sine. Except not multiply right there, because that can't go into the hue, which means we need to multiply this. Or rather, we need to... Arctangent works in negative numbers. Oh, but double negatives gives us positive. It's symmetric across this axis because this goes minus. This entire corner, yeah, that's because this entire corner is a minus, this one is a minus, this one's a plus, this one's a plus. When what we instead want is we want this entire section to be a plus and this one entire section to be a minus. How would we achieve that? Well, if we multiply the left by a minus, that works. So we need to take a sine of x and then multiply right here. That's not quite. No, we don't need to multiply by a minus, we need to add to it. Goodness gracious, me, is awful. No, we need to multiply by a minus, yes. And only after we've multiplied by a minus, we need to add to it. No. What am I talking about? Add 1, divide by 2. Add. Multiply by pi. Or multiply by pi divided by 2. Pi divided by 2. This is hell! I have died and gone to maths hell is what happened. Terrible, absolutely horrendous and awful. What we get is horrendous and awful. I have died and gone to maths hell. I can increase the amount of m's in order to make this slightly easier for myself. You can see that as we increase their amount, a whole bunch, like the colors, it becomes easy to tell what's going off wrong. Right. This breaks and this is broken. No, things are broken. Pi by 2. Usually when it goes to constants, 9 of 10. That's good, hold on, that's good. Then to it we need to add pi by 2. Or subtract pi by 2. So close. So close. Oh my goodness. No, that's awful. Wait, no, that's so completely wrong. Subtract 0. This is what we have. We want to first multiply that part by a minus. So multiply we multiply the wrong side, which means subtract from 1. No, we didn't. Good. That's brilliant. I will multiply it by 0. I'm fine. Obviously this is not gonna work. Multiply by -1, make it a bloody moron. -1. Okay. We have this. We multiply by -1. And it goes all red. It very much should not. Oh no, it does make it go all red because no, never mind. It doesn't. No wait, because the add 1 isn't there anymore. Why isn't add 1 there? There we go. Now multiply by -1. Yes, kind of. Actually, no. Don't add anything. Just multiply it. Don't multiply it, just add to it this. No, that doesn't make any bloody sense. Zero. This is what we get. Why is it that once we add? What is it that you're trying to do? I haven't been paying attention. Basically, I have a Cartesian plane where each point has an x and y coordinate, and what I'm trying to get is I'm trying to get the angle alpha of that point. It's a bit more complicated than that because I need that angle to be normalized in a certain way, but, well, that doesn't matter. The point is it isn't working. Because right here, this should be 0, this should be a 1. And this should also be a 1. Oh, I think I found the problem. The bottom, this goes 0 to 1, this goes 0 to 1. When in reality we want it to go 0 to 1/2. So we need to divide the whole thing by 2. Promising. Why does the red right there should be... One of these reds should be a 0, and if you divide 0 by 2, I'm pretty certain it still is a 0. Last time I checked. At 1. I have such a headache. Arctangent has gives you a value from between -1 to 1, which means that if we take the arctangent, if we add 1 to it, then it gives you a value from 0 to 2. If we divide it then by 2, what we should get is a value from 0 to 1, which in this case should be very much, as far as I'm aware, 0, 1. 1, 0. Right here we have a right here we have a line of undefined values. Now, right. So, wait, this gives us 0 to 1. We don't want it to give us 0 to 1. We want it to give us 0 to 1/2. Which means we would divide it by 4, actually. Now it gives us 0 to 1/2. And now we want to add 1/2. I think I've nailed it. I am really hopeful for this one because this actually makes sense. Yes! It will break if it's not an even number. Yeah, as you can see, that's why the colors didn't make... Damn it! Because the colors aren't defined on this line. That's always something! The colors aren't defined. I mean, the way we can fix it, which is a pretty terrible fix, but it is fx, is we can just add a tiny error value to the x-coordinates. That is from one problem to another. For sufficiently high values, it looks correct. But actually we still get an error like this. Oh wait, it's because we haven't plugged this in as well. Never mind, now it should be fine. Yeah, it looks pretty terrible for a small thing, but what we should do is we should do truncated modulo of 2. This will check if it's an odd number, and if it's an odd number, then we're going to... If it's an odd number, then... How do we select the middle point? Divided by 2. Floored. Yes. Divided by 2. And then you take the floor of that value. Now if our index compare, if our index on both of these is equal to this, and the thing is odd, then we want it to be white. Okay, so this plus 1. Well, that's curious. That's a negative, that's why, isn't it? Shit. It's why you always have to be like that. It's a negative. Which means that right here should still be this, but then should be multiplied by -1. Oh, even then it isn't working, because we added 1 when in reality we should have subtracted 1. No? Add 1. Why does it... Whoa, 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 that doesn't make any sense. I am going to have a stroke, is what's gonna happen. How did this... What? I am so confused. This doesn't make any sense. What? This one is comparing with the x coordinate. This one is comparing with the y coordinate. Why are they both moving on the x coordinate? Screw it. Just piss off with that. Separate off this. If x and y... Oh my goodness, there is actually a much easier way to check this. I'm an idiot. We don't need any of that. All we need is just to do this. And then swap it around. No, wait. No. Because we were looking for zeros, which means it's going the wrong way. We have 2 zeros. When both of these are zeros, if... Ah, no, that's not gonna work either. This is a bit unnecessary, but like, I can just compare these two. It's a bit too fancy for no reason. Basically, I'm comparing if x plus y is equal to x times y, which, as far as I'm aware, should only happen like this, right? That's correct. Oh no! Oh no! No, it doesn't work. How do you check if 2 numbers are both 0? Mathematically. I don't have to do it mathematically, by the way, I just want to. What I can do is I can just do compare to 0 and multiply the results. I could also do it with logic statements, I just don't feel like it. So this two, just check if they are both equal to 0. There we go. Oh, I guess I could also do it this way, which is just a little tiny slightly bit better. Also, I could do it even better, which is that ooh, I could do it even better. I'm over-engineering this like crazy. I'm genuinely over-engineering this like crazy. Yeah. For no reason whatsoever. I just remembered that I'm on a time limit and I wanted to like finish this video quickly or something. And I've spent the entire time doing this. Oh, that's ridiculous. Oh, what happened to the thing? Oh, I unplugged it. Right, of course, because I got too busy working on other stuff. I very much am on the time limit, and I just made a... What's the problem happening now? Oh, there's no problem, I fixed it. But I did just spend like solid half an hour making a geometry node setup in which I just have a single number that defines the size of a matrix and it just generates that matrix. Completely unnecessary. Some would even describe it as a massive waste of time. Okay, right. Taylor expansions video is what I was working on, I remember now. English. Tricky. So cool. So hurry right here because of the line function. It's rising low right here because it's following this sort of thing. Because in the previous we're talking about slope. Times diff plus perturbatively plus so. Third order derivative, fourth order, fifth order, and let's just stop for now, right here. Splendid. Now, right. I had some kind of idea, I remember, like half an hour ago, before I was doing all this. I already forgot what the idea was. Well, I can't, I suppose, treat it as a temporary function, which would be a bit silly. But it would not exactly not work, so... something. It is certainly something. Okay, anyhow. I mean, I'm gonna go, because this has been quite something. Next live stream should happen in around 6 hours. By that time, this video should already be finished, and I should be... and it will be a different kind of live stream. A kind that I think will be a lot more fun. You'll see, foreshadowing. And for now, that'll be it. Thank you so much for watching, and have a great day.